All right, so today we're going to talk about measures of central tendency, and we're introducing our unit of statistics. So we've got some definitions to write down, so feel free to pause this anytime you need to. But we're going to talk about different types of data, different groups. And the first group you've got here, we're going to call qualitative data. And that is data that can be put into categories. For example, your favorite food, your favorite school subject. It could be gathering data on hair color. That would be called qualitative data. It's categorical. Okay, so that's the first thing that you need to be aware of. And we're going to have a second group of data. We're going to call it quantitative data. So pause this to write that down, and then we'll go on to quantitative. So quantitative data is more data that you can measure. So if it has a unit and it can be measured, there's your quantitative data. So some examples of that would be time, measuring time, age, distance. Okay, those all have measurements. Now let's move on, because this is about measures of central tendency. And measures of central tendency are basically, that's your mean, your median, and mode. Those are all different kinds of averages. So measures of central tendency. It measures what is average. And the most common one may end up being your mean. Your mean is the average when you add up all your values and you divide by how many values you have. So that's your first measure of central tendency. The average that you're familiar with. You add and then divide. Then you have your median. That is the number in the middle, but your data has to be in order when you find the number in the middle. When we go on to box and whisker plots, we're going to be dealing with a lot of medians. So put your list in order, find the middle number. If you have two numbers in the middle, we'll go about explaining how to find what your median would be in that case. And then you have your mode, and that is the number that occurs most often. So another term you need to be familiar with is variation, and that is how widely your data varies. So a term that typically goes with mean, median, and mode is your range. And your range is telling you how widely your data is varying, because your range is your high number minus your low number. So again, pause when you need to and get this written out, because we'll go on and do some examples using the mean, median, and mode, but we're going to focus on median. Okay. Let's talk about what a quartile is. When you have a list of data, when you break it up into 4 equal groups, you're breaking it up into quartiles. Okay, arranging it into a set of 4 groups. And you need to know where to make your split. Medians are what you are looking for. These are values that you will need when we later talk about creating a box and whisker plot. So let's say this line represents your list of data. And if you want to break it up into 4 groups, the first thing you would do is split it right down in the middle. You've got 2 equal groups now. Well, that's finding your median. We actually call that the second quartile, but it is the median of the entire list. All right, so that is actually quartile 2. Now you have two groups of numbers. Your next split is going to be looking at the numbers to the left of that median, and you need to split that in half. That's called your first quartile. All right, that can also be referred to as your lower quartile. And that's the median of your lower half. Okay, so this right here would be quartile 1. We now have two smaller groups there that are equal. We need to do the same to the other side. So you're now going to take the numbers on the upper end of your list and split that in half. That's finding another median. That is called your third quartile. Okay, or known as your upper quartile. And that is the median of the upper half. So this is quartile 3. All right, so let's practice finding these values here from a group of numbers. All right, let's say we have 45, 71, 79, 82, 88. Let's do another 88. 90 and 94. All right, so I've already went ahead and put them in order for you. We need to find the quartiles. So the first one you find is actually the one right in the middle, the median of the whole list. So we have 8 values here. So 1, 2, 3, 4. Middle, 1, 2, 3, 4. I don't actually have a number here, so I need to find the number that would be right in between the 82 and the 88. So some of these values may not actually be values in your data set. So if I find their average, that is going to get me an 85. That's actually called my second quartile. I just refer to it as the median. All right, next on our list, our first quartile. That is when we go to the lower half. So now we have split this. We have the 85 right here. We have a new list of numbers. We have 4 of them. Again, our middle is right there. We don't have a value. We need to find the middle of 71 and 79. And that will get us a 75. All right, we need to find our upper quartile, the third quartile. So we need to take our list and take the upper half. You always go to the right of your median. Never include the original median. Never include that value, even if it's a number in your list. Never include it when you're finding quartile 1 and quartile 3. Always look to the right of it, or in this case, to the left of it. All right, quartile 3, we are right in between an 89 and a 90, which I can figure out to be an 89. All right, there are 2 other values you're going to need later on. including these quartiles. You need to know your lowest number and your highest number in your list. Your low number on this particular list is a 45. The last point you need is your highest number, and our highest number is a 94. Later, we're going to put all of these values together and display our data with a box and whisker plot. And these are the values you need, these 5 points. So to wrap this lesson up, I want to go over a couple more terms. Using this data, you need to know what an interquartile range is. Your regular range would be your high number minus your low, so 94 minus 45. That tells you how widely your data varies. But there is also something called interquartile range. Or IQR. And your interquartile range is simple to get once you have these values here. Okay? It is the range from your first to your third quartile. It is the range of these numbers. So if you do high minus low there, you're talking quartile 3 minus quartile 1. And in our case, that would be 89 minus 75. So we'd have an interquartile range of 14. So that's another term you need to be familiar with. And the last thing I want to talk to you about is what an outlier is. And some of you might know that term. All right, your outlier is an extreme value. It's in your list of data, but it's very extreme compared to the other numbers in your data. Very low or very high. Now, there are some numbers that may not look like they're outliers, but they are. Or sometimes you'll have a number that does look like an outlier, but it isn't. So there's actually a mathematical way that you need to determine if a value is an outlier. In our list, it looks like the 45 is an awful lot lower than the rest of the values, possibly an outlier. We're going to use this information here to prove that it is an outlier. What you need to do is you need to find the lowest value you can be before you become an outlier, or the highest value you can be before you become an outlier. And here are the steps you need to take to do that. The first step you need to take is take your interquartile range and multiply it by 1.5. It's always going to be by 1.5. So let's do this with our list. Let's prove that that 45 is an outlier. Our IQR is 14. We're going to multiply that by 1.5, and that's going to get us a 21. I'm going to call that value X. Our X is a 21. We now need to find the lowest number that we can be before we become an outlier. Here's how you do that. Take what your first quartile is and subtract the value you just found for X. We are finding our X to be a 21. So here's our lowest value. Q1 is a 75. If I take away the 21, that is going to get me a 54. That's the lowest I can go before I become an outlier. If I am lower than a 54, I'm an outlier. So we have just proven we have an outlier here. But let's say we had an extremely high value in our list. Let's see what the other boundary is before we become an outlier. Take your third quartile and add whatever that value was you found for X. So in our case, our third quartile is 89. If we add our 21, we end up getting a 110. So if I had an extreme value, if it were higher than 110, it would be an outlier. Lower than 110, it wouldn't be an outlier. So you'll have some outlier questions, and I want you to be familiar with how to work with those. All right, we'll discuss more of this in class and go over any questions you have.